Hi everyone, my name is Miss KM. Today I'm going to be talking about pulses. What is a pulse? Well, in grade 10 you need to know what a pulse is. A pulse is a single disturbance. Just two words, single disturbance. What do I mean by single disturbance? Well, by single disturbance I would mean that a single disturbance is basically movement from point to point. So, movement from point to point, like it's the single movement with a substance. As you look at this diagram over here, this entire diagram is a wave. Now, in depth of a wave, you can see, what do you see? You can see these things that move up and down, up and down, up and down, and that over there are pulses. Over here, as you can see, this whole thing, this moving up and down, those are pulses. Now, over here you can see these funny words and funny labelings you'd never even heard of your life. So, over here is crest. What is a crest? A crest, it's the highest point of a wave or pulse. It's the highest point of a wave over there. Oh yeah. But I'm sure someone is saying, hey, isn't this also a crest? No, it's a trough. Let me differentiate for you. Crest, it's the highest point in a wave. Trough, it's the lowest point in a wave. So basically, up, down, high, low. Crest, high, trough, low. Crest up, trough down. So crest is the highest point in a wave and trough is the lowest point in a wave. Now over here you can see wavelength. You can see we can basically say that a wavelength, it's the distance between these two crests, the distance between these two troughs. So let me give you a simpler definition. Some textbook will give a long definition, whereas you can just say it's from crest to crest. It's the distance between two successive crests. As you can see, crest is the highest point in a wave, as you can see, and trough is the lowest point in a wave. That's why I put a dot there. I don't want you guys to say this whole entire thing, where you can just label it as there on the top. So let's remember, crest it's the highest point in a wave and trough is the lowest point in a wave. And wavelength, simple definition, I would give it as distance between two successive crests, or just distance between two crests. There you go. Distance between two troughs. It doesn't have to be crest alone. It can even be trough itself. But the better definition I would give it as, it's just the distance between two successive crests. So distance from these two and distance from these two. Now I'm sure you guys are looking at, and what is that word over there? Yes guys, that word over there is amplitude. Amplitude, basically I put an arrow there. Amplitude, it measures how big a pulse is. So yes guys, there's no different name for the one at the bottom. It's still the same, amplitude and amplitude. So basically guys, amplitude, it measures how big a pulse is. So this over here is an amplitude, this over here is an amplitude, this over here is an amplitude. So basically amplitude is basically the inside of a pulse. It measures how big a pulse is. It measures how big or small a pulse is. So this over here is an amplitude, so this pulse is small. This over here is an amplitude, so this pulse is big. What else? Over here, yes, rest position. Well guys, rest position, it's where there is no wave passing through. So I even drew a small diagram over here for RP. I just shortened it myself for you guys to understand, because there's no space to write it through here. It's rest position, or another word for rest position in physics, it's equilibrium. So basically, if this is where the pulse stops, then the rest of this line is called a rest position. If this is where the pulse stops, then the rest over here is the rest position. So if I just like remove that, if I just remove that other side, and then you can see that line over there, that line that I just like, the last line over there. If I just remove that, let me just do that. Yeah, and you can see a line after the first pulse, after the first disturbance. You can see that that is a rest position. So basically, if you guys couldn't see, over here, when I remove this whole thing, over here you could see that that is your rest position. If the pulse stops and you just see a whole line like this, that is your rest position. Where the pulse stops, where the wave stops, where the pulse or wave stops, that is where the rest position will occur. Now, moving onwards, this over here, guys, this is a straight line. Now, some of you guys, I'm sure maybe some of you have understood or have not understood by what I meant of disturbance. So now, guys, a disturbance is the one that causes the movement of pulses to occur. So if you can see the straight line, it means there is no disturbance. But if I just draw something like this, if I just draw that over there, it's a pulse, of course, and what is causing that pulse is a disturbance. So if you see pulses, you'll say, oh, it means a disturbance has occurred. But if you just see this, you'll just see nothing. So it means that there's no disturbance, no action occurring. Think of a single disturbance as an action. If there is no action occurring, then it means like there's nothing, there's no drama if there's no action, you see. So this line over here, it means that there's no action, nothing is happening, means that there's no disturbance, no pulses. But if a single disturbance occurs, then this is what you will see here. But if there is no single disturbance, then it's just a straight line. Okay, let's move on. Now, this long definition I got from my textbook. It says that transverse pulses are when particles move at right angles to the direction of propagation of the pulse through a medium. Now, this long definition, you can just say, I know some of you might say, oh, it's just taking out words, just putting in your own words. Well, you can just put this definition. It might be similar to this definition, but I'm sure it is useful. So basically, transverse pulses are when like particles move at right angles to the direction in which the pulse is moving. So when a pulse moves, it moves at right angles. An example of a transverse pulse can be a slinky or a rope. Thank you guys for watching. I hope you enjoyed this video. Please like and subscribe. Thank you. And leave comments down below.